Welcome to today's presentation, Shrinking Big Data Challenges by Connecting Hadoop and Postgres. My name is Sandra Vicky, and I'm Director Product Marketing here at Enterprise DB. I will be joined by my colleague Ahsan Hadi, Senior Director Product Development. We would like to introduce the EDB Postgres Data Adapter for Hadoop to you today. The Data Adapter allows the integration of Hadoop data into traditional enterprise applications using EDB Postgres. What do we have on the agenda for today? First, I would like to tell you about EDB and how we deliver an enterprise-ready Postgres platform. Then I would like to look at data today and how it is created and used. Afterwards, I will introduce the EDB Postgres Data Adapter for Hadoop, and you will see what the capabilities are and how it will allow you to integrate data from Hadoop with data in EDB Postgres. Then it's Ahsan's turn to show you a demo of the integration of Hortonworks Hadoop using EDB Postgres. After the demo, I will summarize today's presentation and give you a few links to learn more about the EDB Postgres Data Adapter for Hadoop. PostgreSQL is an open source relational database management system. Its development starts in the open source community, delivering a mature database with many advanced features already included. Postgres' popularity and its open source heritage mean for you no vendor lock-in, fast development cycles, and thousands of developers. We at EDB then take open source PostgreSQL and add enterprise-class features and tool suites, as well as services and support. This will allow you to run Postgres reliably in production. Our added value is 24/7 global support to help you resolve issues quickly, services to support you to implement and tune Postgres, training to enable your team to work with Postgres more productively. As a product company, we have a roadmap for our database features and tools. Many of our features were developed based on customer demand. The benefits of the enterprise-class features include better performance, improved security, and a compatibility for Oracle. On top of that, we developed tool suites for manageability, integration, and migration. Now let's look at the EDB Postgres platform so that you can see where the data adapter fits in with EDB Postgres. What we really want to show you here is that EDB Postgres is more than just a database. The platform also provides you tool suites, services and support, and really helps you to make the best out of your Postgres deployments. With a wide range of deployment options for on-premises and the cloud, it includes everything that you need to adopt Postgres in the enterprise. Our standard subscription includes support for the open source PostgreSQL database, which you see at the top right, and at the top left you see the EDB Postgres Advanced Server database, which is included with our enterprise subscription. Many of our customers run PostgreSQL, and they come to us for support and to take advantage of our tools. Some of them are EDB Postgres Enterprise Manager for monitoring, tuning, and management. And then we have tools like EDB Postgres Backup and Recovery or EDB Postgres Replication Server. And this solution is good for lots of workloads. But the majority of our customers, they run EDB Postgres Enterprise with the EDB Postgres Advanced Server. It has the additional features of added security, improved performance, and the database compatibility with Oracle. And this solution is a great fit for workloads with many concurrent users or lots of transactions. So this slide is titled Data's Everywhere. And what we want to show you here is that we have new data types. Over the past years, the type of data has really changed. It has become very big and various. So the sources might be social media. We didn't have that 10 years ago. Or we store a lot more data about customer interactions. If you run a web store, you would have a purchase history or transaction logs. If you are manufacturing, you might have sensor data, and if you run a web server, you would have lots of web server logs. If you want to store them, what do? previously you had mostly relational databases where you'd store that in PostgreSQL, in Oracle, or SQL Server, for example. But nowadays, for this new type of data, other databases or data stores have evolved. So what we see here, there's CouchDB, there's MongoDB, there's Cassandra or Hadoop that we're talking about today. So the type of data has changed and the data stores have changed. But the issue with that variety of data stores and databases is that we are creating more and more data silos. And as data silos, we see data that is isolated. So data that would be only used by a particular application or particular applications, but the data is not necessarily available for company-wide reporting and analysis. So the way to join data together to avoid having just data silos is what we call a data platform. A data platform in this case would be EDB Postgres, and it would be used to integrate those external data sources with other company data and to make it available to users and applications through a SQL interface. And SQL is a well-known standard. It's known by users and applications. So even if your application doesn't support one of those data stores like Hadoop or MongoDB, your application can work with that data and it becomes accessible through the data platform through EDB Postgres. So speaking about Hadoop, I would like to mention the HDFS, which is the Hadoop Distributed File System. And this is a file system which is very good for storing large amounts of data because of its horizontal scalability. What the EDB Postgres Data Adapter does, it connects Hadoop to this HDFS data. And the way this works is when you set it up, Postgres will see the data in Hadoop like it would see data in its local tables. And this is very good for large data processing because you are able to leverage the benefits of HDFS, so the horizontal scalability and the benefits of a relational database management system like Postgres. EDB Postgres will also provide this data, make this data available to users and applications using a SQL interface. So what it does is, even if your application doesn't support those external data stores, it will be able to use that data because you will provide it to them in a structured way that can be queried by SQL. And by doing this, what you do is you create a data platform, so you will be able to not only use data from one data base, but you will get a complete overview of a particular process or customer. For example, you can create better insight to an end-to-end process, or you can create a 360-degree of a customer. And last but not least, we work with our partner Hortonworks. They provide Hadoop like we provide Postgres in an enterprise ready way, and they have just certified our EDB Postgres Data Adapter for Hadoop with their Yarn Ready Batch certification. On this slide, let's take a look at the SQL that the Data Adapter allows you to use with the external data sources. So, as I said earlier, the external data sources are seen by Postgres as if it were local tables. So what you can do select statements, including distinct, order by, or group by. You can join data from external data sources with data in EDB Postgres. And you can use functions, for example, for math, for pattern matching, and other functions as well. The benefit in performance for the data adapter comes with the predicate pushdown of, at the moment, select and where clauses. So if you have a where clause in your query, then this will be pushed down to the external data source, so the results that you get will only include that data. On the roadmap for the data adapter, at the moment it is read-only, but the next version will have a read-write capability, so you will be able to do inserts, updates, and deletes. And with that capability, there will also be the ability to do bulk data transfers. And in order to improve performance even further, we're working on a predicate pushdown for the join, for limit, and for the aggregates and sorts. For those of you already working with Hadoop, you will have Hadoop and you will also have a Hive server. We have this slide in the presentation because of what Arsan does later in the demo. And when you see what he does, you will see that EDB Postgres will be connecting to not Hadoop directly, but it will be connecting to the Hive server. He will also show you what needs to be set up in the Hive server to connect to it via EDB Postgres. So this slide, I mentioned the demo in the previous slide. This slide shows you the cold run of what Arsan is going to do live in a few minutes. What he will not show you, but it's a requirement to use EDB Postgres. We have to install it. We have to install the EDB Postgres data adapter for Hadoop on top of it. Then in the Hive server, there needs to be a table mapping available for EDB Postgres to access. And within EDB Postgres itself, when you connect to your database cluster, in the database cluster, you need to load the EDB data adapter extension. That's where Arsan's demo starts. So he has already installed EDB Postgres and the data adapter. He will then load the extension. He will then create a mapping in Hive. And then he will go into EDB Postgres and he will create a connection definition for the Hadoop server or HDFS, the Hadoop file system. He will create a user mapping between EDB Postgres and Hadoop. So at the moment, the EDB Postgres user name has to match the Hadoop username, but in the future there will also be a user mapping, but at the moment they have to be equal. And then in order to really access the data in the Hadoop files, what you need to do is create a foreign table or define what they call a foreign table, and this definition has to match the definition of the table in Hive. But yeah, it's better to see what Arsan does later, but this gives you an overview of what he will show you. Okay, Arsan, this is where we will have the demo. Thank you very much for presenting this to us today, and off you go.
Hadi. I'm a Senior Director of Product Development with Enterprise DB. Today in this short video I'm going to show you how Hadoop Data Adapter from Enterprise DB works with the HDP. HDP, as you all know, is Hadoop Hortonworks data platform, which is an open source distribution of Apache HDFS and its related components like Hive. HDP provides with the ease of use interface and an installer that can be used to install Apache HDFS and its related components. It also provides you with the monitoring tool and a web interface to manage the HDFS cluster and monitor the cluster. So in the video today I'll show you how Hadoop Data Adapter works with HDP and how it can be used to access the HDFS data from from a Postgres Plus Advanced Server database. So before I go into showing how Hadoop Data Adapter works, in order to carry out this demo, I have instantiated an instance of HDP 2.3 on Azure. As you can see on your screen, I have an instance of HDP running on Microsoft Azure. You can either instantiate an instance of HDP on Azure, or you can download a sandbox VM from HDP that also has all the Apache and its related components. So for this demo, I have instantiated an instance of HDP on Azure. I also have the Ambari interface here. The Ambari interface is a web interface from Hortonworks that is used to provide monitoring tool for HTTP. On the left, I have there's a list of all the Apache components: HDFS, Yawn, Hive, and using the Sambari interface, the user can configure each of these components. So later I'll be showing you, how we can how we use some of these components using the Sambari interface. So what I've shown you already, that I have an instance of HTTP Hortonworks Data Platform running on Azure, and I also have the Ambari interface configured that I use to manage and monitor the HDFS cluster. Okay, so I also have another VM on which I have installed Postgres Plus Advanced Server, and it also has the Hadoop data adapter installed as part of Postgres Plus Advanced Server. Enterprise DB is planning to release the installers for Hadoop data adapter pretty soon. The user will be able to, using the installer, install the Hadoop data adapter. So let me just show you how the version of Postgres that I have on this machine. So I've installed Postgres Plus Advanced Server 9.4.1.3 on this VM that's also hosted on Azure. Next what we need to do is start configuring the Hadoop data adapter and demonstrate how it works with the HTTP. So in order Hadoop data adapter is basically an extension of Postgres Plus Advanced Server. Postgres Plus Advanced Server has a number of extensions, that are added to the database server, and the purpose of these extensions are to provide additional functionality. In this case, the Hadoop data adapter extension is provided to provide connectivity between Postgres Plus Advanced Server database and HDFS, and allow the users to access the HDFS data from Postgres Plus Advanced Server database, as well as perform all the SQL operations that are stored on the data in HDFS. So in order to create the extension, we need to run a create extension command. So I'll just go ahead and run the create extension command, which is create extension HDFS underscore foreign data wrapper. So that basically creates the Hadoop data adapter. The next thing we need to do is create a server. This is the foreign server that will point to the HDFS instance that we have running on HTTP on Azure that I showed you earlier. So I'll just do a create server HDFS server command, and then as you could see in the options, I have the host, which is http4.cloud app.net. That's the Azure instance where I have the instance of HTTP running. The port number is 10,000. That's the port for Hive Server 2. The client type here is Hive Server 2. The Hadoop data adapter uses Hive Server 1 or Hive Server 2 in order to connect to HDFS. So in this instance, we are using Hive Server 2, and the port number for that is 10,000. We also have a couple of other parameters that are used to define timeout. So we have connect underscore timeout, which is set to 10,000 milliseconds, and receive underscore timeout, that's also set to 10,000 seconds. Basically what those two parameters do is, if you are trying to connect and due to a networking failure, or if the HTTP instance is down, the data adapter is not able to connect, to HTTP, then it will time out after 10,000 milliseconds. Similarly, if the query is running on the HDFS side, and there's no data being received for 10,000 milliseconds, then the query will time out, and you'll get an error from the Hadoop data adapter. So after I've created a server, the next thing is to create a user mapping. The user mapping is basically used to provide a user mapping between the Postgres Plus Advanced server and the HDFS server. Right now, we don't support authentication with the Hadoop data adapter, so the user mapping that I've created is only created as a no-op, but later on when we provide authentication support, then user will be able to provide username and password that will be used for mapping users from Postgres Plus Advanced Server database to to Hadoop. After I have created the user mapping, the next thing to do is create a foreign table, and I'll just show you the foreign table, and then I'll explain you how the mapping works. So as you could see, I'm creating a foreign table web logs here. The web logs foreign table basically corresponds to a table in Hive that is also called web logs, as I've specified in the in the options section. And the name of the database is default. That's also the Hive database interface. I'll click on the landing page here. On the landing page, you can click on the top right hand menu, and you'll get a drop down where you can look at the HDFS file browser or Hive. So first of all, we look at HDFS files. So when you click on HDFS files, you basically get a list of all the directories, HDFS directory that you can browse. In for this demo today, we are using an example of weblogs data. So I've uploaded some weblogs data to HDFS that we will be accessing from Postgres Plus Advanced Server using the Hadoop data adapter. So if I click on apps and Hive and warehouse, you can see that I have a weblogs directory here. That's where I have uploaded the weblogs underscore parse.txt file, which is only a 77 MB file, but that basically has that's the text file has all the weblogs, that's all information about accesses to the website. So this is the test data that I've uploaded on HDFS. Usually the weblogs data is very huge in size. So for a typical customer, you would basically see weblogs in gigabytes or even terabytes. But for this use case, I'm using a small file which is only 77 MB. So I've uploaded that file using the new directory and upload buttons that are provided by the Ambari interface. So next, I go to the top down menu again and I click on Hive. This is the Hive view from Ambari interface, and on the left you can see the databases. So this is the default database that I showed you earlier. So if I click on the default database, I can see all the tables that I have created, and I have the web logs table here. So before you can actually create, before you can access the data through Hadoop data adapter, you need to create a table in Hive. So I've created a table using this interface. So I'll just quickly get that table from our enterprise DB Hadoop data adapter uh, documentation. So all I need to do is basically paste the weblogs, create table statement here, and hit the execute button, and it'll basically go ahead and create the weblogs table. So I can also query the weblogs table using the Hive interface. So I should be able to do something like select static from weblogs limit 1 and hit the execute button, and it should actually query the weblogs data file that I showed you earlier, and it'll basically get that data back. All right, so it's just trying to run that query. and should see the result any minute. As you can see, the status of the query is running, and now it's succeeded, so I should be able to see the results here. So I've only requested to bring one record back, so it's bringing one record back from the file. So this is the Hive interface. Now I'll go back to the Hadoop data adapter. So as you could see, I showed you earlier, we have created the foreign table, and that foreign table maps to the web logs table in Hive, and the web logs table is part of the default Hive database that I've showed you earlier. So if I click enter here, I can go ahead. The weblogs foreign table is created. Now I can just simply use the foreign table as as a normal table. I'll run the queries that I showed you earlier, and some more complicated queries. So I'll just run the query that I ran Hive, that basically queries the web logs foreign table and gets one record, from HDFS. So basically, as you could see, I ran a query on the web logs foreign table, and which only returned one record because I used the limit one clause here. So this is basically using the Hive table that I showed you earlier, and it's getting data from HDFS that's running on HTTP platform using the Hive server too. So I'll run some more complicated queries to to demonstrate to you the usage of Hadoop data adapter, which provides us with this SQL view of HDFS data, and the user will be able to perform all the SQL operations against that data, in order to perform your analytical queries, or more complicated queries on your Hadoop data. So next, I have another query that I'm going to run, and this query basically concatenates multiple fields from the weblogs file, and it orders the data by date time, and it limits to 20, so it's only going to get 20 records from the weblogs data in HDFS. So this query should hopefully return the results shortly, and after this query, I will show you how we can join a local table from Postgres Advanced Server, and basically join that with the foreign the weblogs foreign table, and how the join operation would work. See, the query came back with 20 rows, and it is basically done, it's showing the client IP, and it's done some concatenation of different parts of a data that were extracted from from the weblogs file in HDFS. So next, I'll create a local table in PPS, so I can demonstrate how to join a local table with a foreign HDFS table. So create a local table prim underscore IP, and inserted some test data in there. The next query, I'll join the table with the weblogs foreign table that we created earlier, and as you can see, it's going to bring some data back. Alright, so As you could see on your screen, we have the query in there, which is joining the premium underscore IP table with the web logs. Foreign table, it's doing an equi join using the client IP, and we are using the group by operator here, as well as we are limiting the number of rows. And in the where clauses, you could also see that we are only getting the data for year 2011. This where clause is actually getting pushed down to HDFS, so the only data that we are getting back from HDFS is for 2011. This is a performance feature where you can limit the data that travels across the network from HDFS running on HTTP to your database server. So in this case, we're only getting data for 2011, and using the group by here, I'm basically grouping the data based on client IP and category, and showing the number of hits from those IP. So as you could see, you can identify the IP that had the maximum number of hits to the website. All right. Next, I'll probably just do another sample query here, to show some more analytical operation that you can do against the HDFS data using the Hadoop data adapter. So in this particular case, I'm basically, again for year 2011. I'm grouping by client IP, and you know and counting the number of times this client IP is used in the web logs file. So as you could see, the client IP column and the number of time this is used in the web logs. All right. Okay, so that basically demonstrates that we should be able to use all the SQL all the SQL query constructs, aggregates, distinct, against the HDFS data using the Hadoop data adapter. And right now the Hadoop data adapter is a read-only adapter, which means that you can only access the data that's stored in Hadoop. But going forward, we have on our roadmap where we would make this also writable, so you should be able to read from HDFS, also write to HDFS. There are some plans to add bulk data utility to it, so you'll be able to read bulk data or write bulk data batch to HDFS. So that's some of the things that we have on our roadmap. The last query that I want to show you is an explain query that basically what I'll show you is that using this explain plan, the point that I was mentioning earlier, where we are actually pushing down the where clause to HDFS, so we can only bring back a limited set of data. So if you could see the remote query here, which is the remote SQL row here, you can see that we are actually sending the year 2011, pushing that clause to HDFS Hive, so we are only getting data for 2011. So this is a performance feature which allows us to only get a smaller set of data across the network. Alright, so in this demo I have shown you how to use the Hadoop data adapter, how you can upload files to HDFS using the Ambari interface, and how you can create the table in Hive, and how you can create the Hadoop data adapter extension, as well as all the related SQL objects that are used in order to access the data stored in HDFS. Thank you very much.
Thank you, Hassan, for this demo of the EDB Postgres data adapter for Hadoop with Hortonworks. We have seen how it works today, how you can set it up, and when you imagine what these capabilities give you, they allow you to integrate other data sources. Well, with this data adapter, obviously you integrate Hadoop data store, but there are also other data adapters, for example, from MongoDB. So with these types of data adapters and the capability of EDB Postgres to integrate in your environment, imagine what you can build from that. So you can really create a holistic view of data and what we call a data platform by joining data from various data sources. And it allows you to use Hadoop for its horizontal scalability while using EDB Postgres for the benefits of a relational database. While Hadoop is organized, or you store files in Hadoop, so it's not necessarily structured data, even though those files have a structure. But we use Hadoop for what we call big data, but the data adapter gives you the ability to process this data in a structured way, and the data adapter also gives you the ability to provide a SQL interface to this big data for users and applications. And after all, the overall benefit is that you can make better decisions and you have higher customer satisfaction. And what we've mentioned before is that having all this data, you can build a much more complete view of things, and things could be customers. So you could build a 360-degree view of a customer with the purchase history, relationships, customer interactions, all of that you can pull from different databases and data stores when they access your website, when they clicked here, when they clicked there, where they went to. You can collect all that information in one place and use that for better intelligence and better decision making. And the same is true for processes. So if you have, for example, a production process, you can start with your data, with your product sourcing, where it comes into production, where it goes through your manufacturing, and where it leaves. So you can really build this type of information in a completely new way to make better use of what you already have. In terms of resources, I would like to give you those 3 links. The first one takes you to our GitHub page where you can download the binaries of the EDB Postgres data adapter for Hadoop. As I said, they're the binaries, so they would need to be compiled if you want to use them. But what you could also do is you could wait a month or 2, and then we will provide you with an installer for an easy installation. So if you wait for the installer, it will be ready for your operating system for you to easily install the data adapter. But if you want to have a look at it today, then go to the GitHub page and you can look at what we've got there. Asan already wrote a blog about connecting Hadoop to EDB Postgres. That's available at the second link, and you can see in writing what we talked about today. And he also has some examples showing you how you can combine data from EDB Postgres with Hadoop. And the last one is one of our press releases. I said earlier we work with Hortonworks as a partner, and they have certified our EDB Postgres Advanced Server and the data adapter with Hadoop from Hortonworks. Okay, Asan, thanks a lot again for the demonstration, and thank you everyone for your attendance today. I hope you like what you saw, and I hope you can see the possibilities that the data adapter will open for creating data platforms and making better use of data. So if you want to work with EDB Postgres and the EDB Postgres data adapters, please don't hesitate to contact us at sales@enterprisedb.com. This is it from the demonstration and presentation today. Have a good rest of the day. Thank you.